Okay, welcome to the lesson on gravitational potential energy. First off, energy, as we've defined before, is anything that changes matter. Another definition of energy is it's the ability of an object to do work on something. Potential energy is stored energy as a result of the position of an object. There's several types of potential energy, including chemical, nuclear, gravitational, elastic, electric potential, and magnetic, as we've learned about already. And in this lesson, we are going to focus on gravitational potential energy. Energy is measured in units called joules. Gravitational potential energy. Gravitational potential energy is the energy stored in an object as a result of its vertical position or height. Gravitational potential energy depends on the mass of an object and the height at which it's located above the ground. In this example, the blue skier has the same mass as the red skier, but the blue skier is at a higher height above the ground. So the height above the ground is the distance from the ground to where the skier is located. And because the blue skier is at a higher height, the blue skier has more gravitational potential energy. And in the second case, over here, we have two skiers at the same height, but the green skier has more mass. It weighs more. He weighs more. And the red skier has a lower mass. So the green skier has more gravitational potential energy even though the green skier is at the same height. So gravitational potential energy depends on how high something is above the ground and also on the mass of the object, how heavy it is. So gravitational potential energy increases as weight increases and height increase. The equation for gravitational potential energy is PE grav, which represents gravitational potential energy, equals mgh, where m is equal to the mass of the object measured in kilograms. G is a constant, 9.8 newtons per kilogram, and h is the height of the object in meters. The units have to be consistent. So mass can be measured in grams, kilograms, pounds. There's many different units, but in order for the equation to work, the unit for mass has to be in kilograms and the unit for height has to be in meters. It can't be centimeters or inches or feet or anything else. It has to be meters. Height is always measured from some reference point. At the reference point, the height is taken to be 0. So the reference point is the distance from which the height is measured. And generally, the height is taken to be 0 at ground level. So usually you're measuring the height above the ground. Here's an example. A tabletop is 1 meter high and has a 1 kilogram book on it. If the book is lifted 0.5 meters above the table, how much gravitational potential energy does it have? So we use our equation PE equals mgh, and we plug in our values for mass, the gravitational constant g, and height h. Note that the gravitational constant g is just a constant. It's a number that's always in the equation. It never changes. If you take Physics 11, we talk a lot more about this constant in more detail and explain it. But for now, you just have to use it the way it is. So it's 14.7 joules. Use this principle to determine the blanks in the following diagram. Knowing that the potential energy at the top of the tall platform is 50 joules, what is the potential energy at the other positions shown on the stairs, steps, and the incline? So here you have a incline, and you have at the top of the incline the potential energy is 50 joules, and then you have 1, 2, 3, 4, 5 stages in the steps. So if we want to find out the potential energy at any location along here, we simply divide the total potential energy by 5 because there's 5 steps. So 50 divided by 5 equals 10 joules. So the potential energy at each step is 10 joules. So it's 0 at the ground because it's on the ground. So at position D it would be 10. At C it would be 20. At B it would be 30. And at A it would be 40. And then at the top it's 50. The potential energy of the object along the ground is always 0. It doesn't matter how you travel up to the top of this staircase. If you travel up the stairs and go up the stairs, or you could go up this incline, or you could go straight up. The path that you take does not change the potential energy at the end, because the potential energy is only dependent on the height above the ground and the mass of the object. So whether you go straight up, whether you go up the incline, or whether you go up the stairs, once you get to the top, the potential energy is always 50. And the potential energy at the bottom would be 0 at both E and F. And that's what's shown here. Okay, now we can rearrange the equation to solve for mass or height. Here's an example. A book is held 12 meters on a shelf above the ground. It has 235 joules of potential energy. What is the mass of the object? So in this case, you know the potential energy, you know the height above the ground, but you're looking for mass. So step 1, write down the given information. We write the word given, and we write down what we know. So the potential energy is 235 joules, height is 12 meters, and we write down what we're looking for with a question mark. So mass m equals unknown. Step 2, write out the equation and put in the values that are given. So the equation is PE equals mgh. We can put in the numbers that we have and leave the variable unknown for mass. And then we rearrange the equation to solve for mass. So we can expand 9.8 times 12 is 117.6. And then you're multiplying the right side by 117.6. So whatever you do to one side of an equation, as long as you do the same thing to the other side, you keep the equation equal. So to get rid of, we have to get m by itself. So to get rid of the 117.6 on the right side, you're multiplying by 117, so you do the opposite. You divide by 117.6 on the right side. And then if you do that on the right side, you have to do that on the left side as well. So you divide both sides by 117.6. This is exactly what you've done in math class before. This cancels, And then we flip the equation around and we get m equals 235 over 117.6. And then we solve. If we get a reoccurring decimal, just round to 2 decimal places. So it becomes 2.00 kilograms. Note, in order to use the potential energy equation, all units must be in scientific units, mass must be in kilograms, and height must be in meters. And that concludes the presentation. You can now move on to the practice question.